Originally, my lathe only had one gear banjo. It was either turning or threading and a hassle to switch from one to the other. No tumbler reverse and no left-hand threading. I modified my lathe so I can easily switch from turning to threading. This is the feed train to which I fitted a tumbler reverse to reverse rotation of the lead screw. This is the thread cutting train which turns gears on a separate banjo. It can be fitted with a reverse idler to cut left-hand threads. By undoing two screws, I can operate the tumbler reverse to change feed direction or engage the threading banjo with a pre-selected set of gears. I drew the positions of the feed gear, lead screw, and lock screw. Then I mapped all the combinations of the threading gears and included the reverse idler gear, to determine the dimensions of the banjo. I start by opening a hole for the banjo pivot which fits over the lead screw shaft. I then bore it out to the required dimension. This is the cast iron retaining nut. It rotates with the lead screw. Being made of cast iron, it also doubles as a bearing. A slot needs to be cut to accommodate for the different positions of the threading gear shaft. I shall first chain drill the slot. I use a punch guide I made to center punch the location of the next hole along the scribed line. It consists of a pin that fits into the drilled hole and a removable punch. The pin is inserted in the hole and the punch aligned with the line. Then the punch is given a good whack. The jig sets the ideal distance between the centers of both holes. Perfect separation every time. The slot to be was chain drilled. An 8 mm ripper end mill is used to cut the slot. Here are the component parts. Edges were chamfered and welded, and the welds ground. The sides were then cleaned up. I need to machine this circular slot revolving around the lead screw. The banjo locking screw shall live here. I shall fit a transfer screw instead of the banjo locking screw, to mark the radius of the arc. The transfer screw is threaded by means of this driver. I made a whole set of them and they come in really handy from time to time. The transfer screw is fitted to the driver and then threaded in the hole. The tip is hardened and will scribe a line. The banjo is fitted onto the end of the lead screw. And the bearing nut threaded on. It then is given a good scratching. Once done, the transfer screw is removed. The banjo is centered in the chuck of a dividing head I made. The base of the dividing head fits in the mill vise. It is composed of two parts which clamp on the chuck shaft. One part clamps to the vise and houses the wheel. The vise is closed to seat the base, and the clamp holding it to the vise is tightened. The other part is movable and is actuated by the vise jaw. It can be fitted with dividing plates. The vise is open to allow the clamps to separate and the chuck to be assembled. The vise is then tightened. Even so, the worm and will mechanism can easily turn the chuck. The hole in the banjo was aligned with the mill spindle and then moved to the arc. The slot was first chain drilled to remove the bulk of the material. An 8 mm ripper end mill is then used to mill the slot. And this is how it works, next to make the shafts for the gears. The material for the reverse idler gear was cut from this cast iron clutch center plate. The gear blank was drilled to be fitted in an arbor. This shall become a Mod 124 tooth gear, and the outer diameter was turned to 26 mm. It was cut to the required length, then drilled and reamed. The dividing head I built is fitted in the mill vise. And the gear cutter to the collet chuck. The gear blank is held in an arbor. I set the top of the cutter level with the blank center. I use the DRO to lower the cutter by the blank's radius minus half the cutter's width. I double check by using a ruler. Since this is a Mod 1 gear, the cutter is fed in 2.25 millimeters. I apply the spindle lock and cut the tooth in one pass. And the reverse idler gear is done. I shall make the shafts for the threading gears and the reverse idler from these two bolts. Here's the one for the reverse idler. The shaft has a number of features that make it a bit challenging to machine. This flap fits in the banjo slot and allows the retaining nut to be tightened. The gear runs in this area here. And the head needs to be very narrow. First, the bolt's head is rounded. Then it's flipped around to turn it down. The part is then transferred to the square collet block I made, in order to mill the two flats. I have a milling machine that fits instead of the compound, but it's a hassle to use. A better one is in the works. The collet block is held in the vise and the collet nut held against the vise jaws. The cutter is zeroed on the shaft and lowered by the required amount. The collet block is rotated by 180 degrees and the cut repeated on the other side. It's then back to the lathe to turn the section that shall be threaded for the retaining nut. And the end was threaded. The excess was cut off. The head needs to be very thin so as not to interfere with the feed gears. This is how it comes together. Two gears fit on the keyed shaft forming a compound gear. I made a small whoopsie when taking measurements, and as the saying goes, measure once, cut twice. I had to recut the banjo and re-weld it, thankfully without scrapping parts. Let's assemble the thing. This is the gear banjo. I shall configure it to cut left-hand threads. The reverse idler gear is fitted in the gear train to reverse the direction of the lead screw. It is omitted when cutting normal threads. The spacer is used to shuttle the gear along the shaft when a compound thread gear is required. Such as this one. Both nuts are left loose to allow for adjustment. This is the feed gear train. This is the threading gear. Both can engage with the lead screw. The lead screw doubles as the feed rod. I modified the feed train so it can reverse direction. I added a stop so the feed gears can be set in neutral. This is the prototype. It still works, but it cannot take all gear combinations nor cut left-hand threads. The banjo is held on the lead screw by means of this bearing nut. It is made of cast iron and rotates with the lead screw. It acts as a bearing and as a nut. A locking screw prevents the bearing nut from coming loose. And finally the banjo retaining screw. The reverse idler is engaged with the gear on the lead screw. The compound gear is then engaged with the idler. And finally the compound gear is engaged with the threading output gear. The threading output gear turns the compound gear, which turns the idler, which turns the lead screw. The feed gears still turn, but are disengaged from the feed output gear. Here's from the side. This is the feed train and this the threading gear train. That's the reverse idler. And it works. Let's see if it cuts a left-hand thread. I remove the idler reverse gear to cut a normal thread. Assembly is performed in the same manner. Now the lead screw turns in the opposite direction. And the lathe cuts a normal thread. Here's the left-hand thread. And the normal thread.